All right, so everybody should be in page 5 of their workbook. Today we're going to be working on our exploring our scaling images. And so we are in block 2 today. And our objective is for us to enlarge and reduce objects using ratio tables and equations. So let's look at this first slide. Will you give me a thumbs up if you can see our slide? All right, I'm getting some thumbs down. Let's make sure this is presenting to where we can see it right. All right, what about that? Can everybody see the regular slide like we're supposed to?
Yes, sir.
Good deal. Okay, so I am going to, would you please, Natalia, would you read this first slide for us, please?
As you saw in the overview, you can use portional reasoning to resize a photo. Tina wants to enlarge this image, but she wants the
Giraffe?
giraffe to look the same in the new image. How can she do this? Play the animation to work through the process.
All right, so we're going to play this and we're going to see what happens. Okay, so looking at that animation, what happened to the original width and length or the original dimensions of this photo?
Got bigger.
Yeah, it got larger. How many times larger did it get?
Three.
Yeah, yes, 3 times larger. So you'll notice that the length, 4, is being multiplied by the scale factor, which is 3, and it gave us 12 inches in length. And 2 inches, which is the width, was multiplied by 3, which is our scale factor, and gave us 6 inches. So if you look at the bottom, what does that say, Kalia, about the scale factor in yellow? Can you read that for us?
The factor by which you enlarge or reduce is called the scale factor. This process applies to more than just images. You can use a scale factor to proportionally change in ratio.
All right. So does anybody have a question about what a scale factor is? All right. So when we think of the word scale factor, what I want you to think about is the scale factor is the number or the factor that is being multiplied by the original ratio. All right. And so we're multiplying that number or that factor by both parts of the ratio. So in this case, 2 and 4 were both multiplied by what number?
3.
Good deal. All right. So we're looking pretty good so far. So let's go on to our next page. We're going to go to page 2. Okay, so let's look at this little puppy. Let's read about him. Brooke, will you read this for us, please?
How you pronounce it? Is that Sunil?
Sounds good to me.
Sunil took a photo of his puppy. He wants to make different sizes of the photo. The original photo is 2 inches by 3 inches. Can you use scale factors to solve the puzzle? Complete the table to create each equivalent ratio of width to length that will produce the same photo in a different size without distorting the image.
All right. So look at this table that we got. Well, originally we have this puppy. His picture is 3 inches by 2 inches. All right. So the width is 2 inches and the length is 3 inches. And they gave us a table with the scale factors already here for us. So all we have to do is take the scale factors and do what to the original ratio?
Multiply.
Good job. That's what we're going to do. So how many people feel pretty confident in multiplying by fractions? Give me a thumbs up if you feel pretty confident. If you don't feel confident, give me a thumbs down, and I'm going to work through one of them with you. All right. I'm kind of getting mixed results. So what we're going to do is we're going to work through this first one where we're working with 2/3, and everybody should be pretty close, okay? So let's see what we can do. So looking at this, we're going to take 2 and we're going to multiply it by 2/3, okay? So I need everybody to understand that the whole number 2 has an understood 1 below it, okay? So what is 2 times 2?
4.
Good.
4.
And what is 1 times 3?
3.
All right. So what we need to do is we need to take our answer, which is 4/3, and we're going to drag it into A. Does everybody see how to do that?
Yes, sir.
All right. So what I want you to do, I want you to try and do the next part B right here with 3. So somebody walk me through what we're going to need to do. Braden, what would we do?
Sir?
What would we do to get B?
To get B, you would do
Jessiana, can you help him out?
for 2, can you do 3 times 2?
Correct. So we're going to do 3 times 2/3, and 3 times 2 is
6.
and 1 times 3 is
3.
all right. And so this is 6 divided by 3. What is 6 divided by 3?
2.
2. All right, that's perfectly correct. And so we're going to take 2 and we're just going to put it into B. Does everybody see how that's working?
Yes, sir.
Good deal. So what I'm going to do is I'm going to give you about 2 minutes to see if you can do the rest on your own. All right, so I'm going to get those 2 minutes started now. And I want you to work on your own on filling this table out, okay? If you need a hint, you can press a hint also. All right, guys, let's see what we come up with. Who can help me with C? Raise your hand if you got C. All right, I'm going to get some help by somebody. Asia, I want you to help me work through getting the answer to C. So just like we worked a while ago, we had to take 2 and 3 and multiply by 2/3 to get our answers. So Asia, what are we going to have to do to get our answers for C and D?
I multiplied 3 times 3 and got 9, and 2 times 1 and got 2.
Great job. And so that would be our answer to D. All right. So you did a perfect job there. So she said she took 3 halves and multiplied it by 3. And this gave her 9 halves. All right. Alora, I want you to see if you can get C. So we're going to do the same thing, except instead of multiplying by 3, we have to multiply by what?
2.
Good. So what is 2 times 3?
2 times 3 is 6.
Good. And what's 2 times 1?
2.
Good. And so this is 6 divided by 2. So what would that be? Or 6 halves. How many wholes would that make?
3.
Good. Is that answer there? Yep. So we're going to put it there for C. Does anybody have a question about how we did those? All right. Who can tell me what the answers are to E and F? Got to participate, or I'm going to just keep calling randomly on people. That's just fine with me. Angel, help me out. What do I need to do to get my width if I have a scale factor of 3.5?
I made it into a fraction of 7/2 and multiplied it by 2.
Okay, and what'd you get?
14/2.
Okay.
7.
Great job. That's perfect. All right. So change into a fraction was fine. I'm going to do it just working with a decimal because I like working with decimals and fractions, but that was a perfect example of how to change it if you needed to. All right. So once again, we can take 3.5, multiply it by 2. 5 times 2 is what?
10.
10. And 2 times 3 is?
6.
And 6 plus 1 is?
7.
And how many decimal places do we have from here to here? 1. So we have to move 1 decimal place. And so our answer is 7, just like we were told by Angel. All right. So we're going to take 7 and put here. And then we're going to see if we can get some help by Miss Brooklyn. Brooklyn, can you help us get F?
I multiplied 3.5 by 3 and got 10/5 in decimal form.
Yes, so that would be 10 and 5. So we would say 10.5. All right? So you did perfect. So we're going to go through that. We'll work that together real quick. So she said she did 5 times 3 and got what?
15.
Good. 3 times 3 is?
9.
Good. And what's 9 plus 1?
10.
Good. And so how many decimal places do we have from here to here?
1.
Good. So we go from here to here. And so our answer is 10 and a half, or 10.5. That's a perfect job. So we're going to take this here. Once we take 10 and a half here, what do I need to do to finish?
Move the decimal.
Look right here in the bottom right-hand corner.
Submit answer.
Yeah, all we got to do is submit it, and we're done. Look at that. Did we get it all right? Yes, we did. So when you look at this, basically what we need to see is that scale factors, they can be integers, they can be fractions, and they can be and decimals, okay? In each case, what did we do with the scale factor to the original ratio? What did we do with the scale factors to the original ratio?
Multiplied it.
That's right. All we did was multiply. Okay, so you should notice that on page 5 of block 2 in your book, that these are the answers to number 1. So you need to fill in your answers in page 5 of your workbook with these answers. And we're going to go on to the next page, which is page 3 in our Chromebook. All right. So looking at page 3, can you read this for us, please, Hagen?
Look at the table you completed. For each photo size, you use the same scale factor to change both dimensions. So the ratio of width to length in each photo is equivalent to the ratios of the dimensions of the other photos. The ratio of width to length for all these photo sizes is equivalent to 2 to 3.
Great job. All right, so looking at this table, this is exactly what we filled out just a second ago. And at the bottom of page 5 in your workbook, question number 2 says, what is a proportion? And so we should see what a proportion is. Jessiana, will you tell us all what a proportion is, please?
Sir?
Can you tell us what a proportion is? It's right here on page 3. I underlined it.
A proportion is a statement of equality between two ratios.
Great job. So when we talk about this, when it says equality, that means that one ratio is equal to another ratio. All right. In this case, it's showing us that 2/3 is equal or equivalent to 4/3 to 2. And it shows us that 2/3 is equal or the same as or equivalent to 7 to 10.5. So we're going to be using proportions in problems that involve scaled images. Okay? So let's continue. Okay, now looking at this, it says that we've used tables and diagrams to explore equivalent ratios in previous courses, which is what we did the other day in our overview. So looking at this table, it says the original photo was 2 inches by 3 inches, and the scaled photo is 4 inches by 6 inches. So since the scale photo is 4 inches by 6 inches, did we enlarge or did we reduce the image?
Enlarge.
That's right. We enlarged the image because it got bigger. So the ratios are equivalent because there is a common factor of 2 between the widths and the lengths of the photo. And so we can describe the relationship between these ratios using a proportion. So we say that 2 to 3 is equivalent to 4 to 6. All right? So if you look over in the right-hand side where it says equivalent fractions, it shows that 2/3 being multiplied by the scale factor 2 is equal to 4/6. Now I need everyone to understand that this right here is a ratio. It looks like a fraction, but this is actually a ratio that has been written in fraction notation. So fractions and ratios are different. And we need to understand that fractions are a numerator being divided by a denominator. Okay? Ratios are one number being compared to another number, or a set of numbers being compared to another number. So what I mean by that is that when we use a scale factor and we have to multiply the ratio, we have to multiply both parts of the ratio. But if we're multiplying a fraction, we're only multiplying the numerator by the number if it's a whole number that we're multiplying by. So this can get quite confusing if you don't do it a lot. So you need to understand that there's a difference between a ratio written in a fraction notation and a regular fraction. All right? So we're going to talk on that a little bit more, and it'll get simpler. I know that sounds like a lot right now, but it will seem easy after we use it a little bit. All right? So looking at this next thing, Kyron, will you read this for us, please?
Yes, sir. Okay. You can also use what you know about equivalent ratio to think about equivalent ratios. Using scale factors and using scale factors to generate equivalent ratios of side lengths is similar multiplying is similar to multiplying a fraction by a convenient form of 1 to create an equivalent ratio. In this example, both the numerator and denominator of original fraction are both multiplied by the same value, 2. So you know the fraction are equivalent.
All right. So identify equivalent fractions or equivalent ratios. We need to find a common factor. And because of the similarity, fraction notation is often used to describe a proportion. And it says that we can write a proportion such as 2 to 3 is equivalent to 4 to 6 by using fraction notation. So if you look, let's move this over. If we look right here where it says 2/3 equals 4/6, this is using fraction notation to show that these two are equivalent or are the same as or are equal to each other. All right? Who can tell me something else, or who can create more than one equivalent ratio to 2/3? And we'll be doing this on number 3 on page 6 in our workbook. So let's try this now. So if we have 2 to 3, we notice that a scale factor of 2 gave us the new equivalent ratio of 4 to 6. So what can I do to 2 to 3 to create a new equivalent fraction?
You would, to create a new equivalent fraction, you would probably have to take it up, like multiply it by something else, and then you'll have to create a bigger number to make it equivalent to something.
Sounds great. So give me a bigger number than 2.
It could be like 6.
Okay, so let's do that. So if we do it to this part of the ratio, do we have to do it to the bottom part of the ratio?
Yes, sir.
All right.
Yes, sir.
So what is 2 times 6?
12.
Good. And what's 3 times 6?
18.
Perfect. Did we create an equivalent ratio?
Yes, sir.
Yes, we did. And it says that we did this because we used a common factor. And our common factor, or in this case, our scale factor, was what?
6.
6. Perfect. So right now we got 2. We got 4 to 6. We got 12 to 18. I want everyone here to create one more and put in your paper on page 3. I'm going to give you about 1 minute to do that, and I'm going to get some answers from what you got, okay? All right, Levi, what'd you come up with?
Okay, so I came up with the scale factor being 3, as if you did 2 times 3 is 6, and 3 times 3 is 9, so 6/9.
Great job. All right, what'd you come up with, Braden?
I did 4. I did 4, and I did 2 times 4 equals 8, and then 3 times 4 equals 12, so 8/12.
All right, that sounds great. Jessiana, did you come up with one?
I did 8 times 2 equals 16, and 3 times 8 equals 24.
All right, that sounds perfect. So that is 3 perfect examples of what we should have. All right.
Wait, Mr. Mark.
Yes.
So about our very first example, the 2 to 3 is equivalent to 4/6.
Yes, sir.
So can we, on our second one, the one that is supposed to be equivalent to, can we make those uneven, or they have to be?
Okay, so we have to, if it's equivalent, they have to be equal to each other. So if they were going to look different, that would make a distorted image, or in other words, it would be not proportional. So right now what we're doing is we're making proportional ratios, all right, meaning that they're equivalent to each other. So if we were to, what we'll get into here soon in the future, if we were to do y divided by x, and find out the constant for both of these ratios, they would all be exactly the same.
Oh, okay, I understand now.
Okay. All right, well, let's keep moving. We're going to go ahead and we're going to move to our next slide. So everybody should have problems 1 through 3 filled out in their workbook. And we're going to page 5 in our Agile Mind curriculum. So let's look what this says. Let's get someone that hasn't taught. Namar, will you read this?
Practice using fractions notation to create some
Proportions?
Proportions of your own. Remember, Samuel has a picture of his puppy that is 2 inches by 3 inches. He wants to enlarge the photo without destroying it. What are some possible dimensions of photo size he could create? Drag the titles to create proportions. There is more than one correct answer. How many proportions can he make?
Great job. All right, so Jessiana, were you raising your hand?
Yes, sir. I'm not logged into that.
Okay, you're not in here right now?
No, sir.
Okay. Right now, what you can do is you can just use what we're using in our classroom right now, what you can see, and just use your workbook, and then I'll show you how to log into it at the end of class, okay?
Okay.
All right. So let's look at this. Let's go with Tamarion. Tamarion, tell me an equivalent ratio that I can use using our fraction notation, and tell me what to put in here for A and B. We just went over some of these.
The 4 one?
All right, so the one we had 2/3 was equal to 4.
12?
There you go. Good job, because that we got that. We didn't have a 4. So we would say 8 goes to A and 12 goes to what?
3.
All right, let's see if that works. All right, that worked out perfect. Kyron, what did you have?
I'm pretty sure this is about to be wrong, but I was gonna say 18.
18 to what?
18, it could be 21. I don't know, because I thought that
You're close.
like,
So what did you multiply 2 times to get 18?
I don't know, I counted in my head. I wasn't
All right. Well, let's talk about it. 2 times 9 is 18. So to create an equivalent ratio, we'd have to do 3 times 9. And 3 times 9 is what? 27. Good. Is there a 27 up here, though?
No, sir.
No, so we're not going to be able to use that one.
Dang it. Okay.
That's okay. Braden, what did you have?
6 over 9.
All right. So what did you do to get 6 over 9?
2 times 3 and 3 times 3.
Perfect. That one worked out great. What did you have, Levi?
I had 20 over 30.
All right. How'd you get that one?
2 times 10 and then 3 times 10.
All right. I always like using that one because it's really fast to do and you can do it in your head, so you don't have to work as hard. Does that sound easy to everybody?
Sir, yes, sir.
All right. Well, I think those are good for right there. So let's keep moving on. So let's look at page 6. All right. So if you would, Miss Anaje, would you read this for us, please?
Yes, sir. You have enlarged photos
Close. Proportionally.
using all of the scale factors you use have been greater than 1. So how can you reduce images
Proportionally. Good.
Play the animation to use a scale factor to reduce a photo. When a scale factor is 1, the two photos are the same size. Drag the slider to see what happens to the image on the right if you see a scale factor between 0 and 1.
All right, so let's make a prediction. If we drag this scale factor and it's going to be smaller than 1, is the picture going to enlarge or is it going to reduce?
Reduce.
All right. And reduce means to do what?
Take away.
To make the picture smaller.
It's going to get smaller or it's going to shrink. It's not necessarily going to take it away unless you went to, a super small number to where you wouldn't be able to see it anymore. But it will shrink the image over the course of time using whatever scale factor we use. So we're going to go through and see what would happen. This is actually your question on number 4 in your workbook. All right, so watch when we get 3/4. What happened when using 3/4? What happened, Rachel?
It reduced.
Yeah, it got smaller. Okay, and so what you'll notice is 4 is being multiplied by 3/4, and so we get 3 inches wide. And 6 is being multiplied by 3/4, and we're getting 9/2. So I want us to take a guess. All right, so let's see, or we'll make an estimate. I don't guess we'll say a guess. Kaylee, if I go to this half, how much smaller is the picture going to be on the right size? What would be the measurement for the picture in width? How many inches, Kaylee?
I don't really understand these factors and all that.
All right, so let's talk about this. What is half of 4?
2.
Yeah. All right. Keegan, what is half of 6?
3.
All right. Let's see if that's right. Does that make sense, Kaylee?
Yes, sir.
All right. Good. All right. Let's look at this one. The next one is 1/4. So how much smaller should it get? About how many times smaller? What is our denominator?
Me?
Sure.
1/4.
So our denominator is not 1/4. The scale factor is 1/4. What is the denominator in that fraction?
4.
4. So that means that our original image is going to be 4 times smaller than what it was originally. All right, because we're multiplying each one of these original dimensions, 6 inches for length and 4 inches for width, by 1/4. So that means that our width will now be what? Levi?
It would be 1, right?
Yes. And then our length is 3/2. Levi, did you have a question?
That I was gonna answer it.
I got you. Good deal. All right, so let's look at this. It says the scale factors between 0 and 1 reduce the figure. Just as when we enlarge a figure, to reduce a figure, we multiply both dimensions of the original figure by the scale factor. The difference is that the scale factor is smaller than 1 or a number that is between 0 and 1, so the dimensions are reduced. What makes a dimension get larger? What does the scale factor have to be? If we enlarge an image, what does the scale factor have to be? Does it have to be bigger than 1 or smaller than 1?
Bigger.
Yeah, it has to be bigger. Good deal. So tell me this. Do the quotients of the length and width stay the same in reductions like they do in enlargements? So say, for instance, we did 6 divided by 4. So I'm going to do that here. We're going to see how many times 4 goes into 6. How many times does 4 go into 6?
1.
1 time. And so when we subtract, we're left with 2. And so this 2 is our numerator. So we get 1 and 2/4, which is equal to what? 1 and a
1 and 1/2.
good.
1 and 1/2.
So if I take any of these other ones, what should I get for their quotient? Should it be the same as this?
No. Yes.
Yes, it should, because that'll make it equivalent. So we're going to check this one with the whole numbers. Let's see how many times 2 goes into 3. How many times does 2 go into 3?
Once.
1 time. And what's 3 minus 2?
1.
So what do we get for our answer?
1 and 1/2.
1 and 1/2. So are these equivalent to each other?
Yes.
Yes, they are. So that does mean that our quotients are the same, just like they are in enlargements. All right, so this lets us know that this table is proportional. Now, what happens to an image when we resize it in a non-proportional way? What happens to the image? Does it look right?
It distorts.
It distorts. So give me an example of distort. What does that really mean to a picture? Like, what would happen to this dude that we're looking at if we did a non-proportional resizing?
He would either get really big or really thin.
All right, so he could get like short and kind of wide, or he could get really skinny and what?
Tall.
Yes. All right. Does anybody have a question about that? All right. So tell me this, are fractions and ratios the same thing?
No, sir.
No, they're not. Remember that fractions are numbers and ratios are what? What are ratios?
You're comparing them.
That's right. It's a comparison of two numbers. Great job. Does that make sense to everyone? Give me a thumbs up if that makes sense. Good deal. Good deal. That's great news. All right. So we have a couple more questions that we need to answer in our work. So when we're looking at our work, the next question we have is number 5. We should have number 5 and number 6, right? So on number 5, can somebody read that question out of their book for us, please? Go ahead, Kyron.
Okay, hold on. No, never mind. Okay. You want me to read all of them?
Let's just do number 5 and then A.
Reinforce. The factor used to create proportional change is called the scale factor. Answer the following questions about the effects of different scale factors. A. Name some examples of scale factors that are less than 1. What effect does a scale factor less than 1 have on dimensions of the image being scaled?
Okay. So what happens whenever a scale factor is less than 1? What happened in this example?
It reduced.
That's right. So it gets smaller or it is reduced. So when a scale factor is less than 1, the links and the sides get what?
Smaller.
Smaller. Good job. So give me some examples of a scale factor that is smaller than 1.
3/4.
Okay, 3/4 1. Anaje, give me one.
I don't know.
Okay, she needs some help. What's one that's smaller than 1, Braden?
Half. Oh, whoops.
You're doing good, Levi. Let's give some other people a chance too, though, okay? Raise your hand if you can give me one that is smaller than 1. Think about what Levi's been saying. Brooklyn?
2/3.
2/3. Great job. Akira?
1/4.
Perfect. All right. Hagen?
1/2.
Great job. So tell me this. What do you notice, Braden, about all the examples that they just gave us?
They're not leading up to a whole.
That's right. They're not a whole number. They're less than 1. So Braden, can you give me a decimal?
A decimal that's not bigger than a whole?
Yes.
1 to 4.
Okay, so like 1/4. So what would that be in decimal? That'd be 0 point what?
4.
Think about it. If you have 4 quarters, makes $1, right?
Yes, sir.
All right, and you told me 1/4. So if you have 1/4, how many is that in decimal form? 0 point what? How many cents would that be?
You said if I have 4 quarters and what?
All right, so you told me 1/4. So if you think of
Yes.
1/4 of $1, which is 1/4, what is 1/4?
25 cents.
It's 25 cents. So the decimal version of that would be what, Anaje? Levi, can you help?
It'd be 0.25.
Correct.
2500ths.
Good job. 2500ths or 0.25. All right? Or 2500ths. Now, we could also say a half would be 0.5. Okay? Does it, Jessiana, were you going to give me one?
I was raising my hand for what you asked Brady, but he got you already.
All right, I got you. Good deal. All right. So it looks like we're doing pretty good on that. Let's read B. Anaje, will you read B for us?
Yes, sir. Scale factors between 0 and 1 reduce the photo just as when you enlarge a figure. To reduce a figure, you multiply both dimensions of the original figure by the scale factor. The difference is that the scale factor is between 0 and 1, so the dimensions are reduced.
All right, so let's look at B on number 5 on our workbook. What does it say? Levi?
Name some examples of scale factors that are equal to 1. What effect does a scale factor equal to 1 have on the dimensions of the image being scaled?
Okay, so if we have a scale factor of 1 And in this case, our original picture was 4 inches wide and 6 inches in length. What happens if our scale factor is 1? What happens to the image?
It's gonna be increased.
All right, you think it would increase? So looking at our example, did it increase at all?
No,
It stayed the same.
It stayed the same. So what if our scale factor was 3/3? Would it stay the same, or would it get bigger, or would it get smaller?
It would stay the same.
All right, so somebody give me an example of one. I've given you 2. I gave you 1 and 3/3. Somebody give me another one. Go ahead, Brooklyn.
4/4.
4/4. Good job. Anaje, did you have one?
2/2.
That's good. 2/2. All right. That's perfect. And what is the decimal version of 1? What could you say?
2.2.2.
Well, that would be 2.2, but that wouldn't be 1. So 1 would just be
1.0.
1.0. Good. All right. I think we were getting our decimal confused with our fraction. But fraction, or our scale factor, if it was 2 to 2 or 2/2, we know that 2 divided by 2 equals 1. So our scale factor would still be 1. All right. And anytime we have a scale factor of 1, the image stays what?
The same.
Great job. All right. Let's look here real quick. Let's get some more help. Keegan, will you read part C for us, please?
Wait, is it in our book? On
Yeah.
page 4?
Correct. Let's see. I really think we're on page 5.
We're on page 7.
Oh, we're on page 7. Thank you.
Name some examples of scale factors that are greater than 1. What effect does scale factors greater than 1 on the dimensions of the image being scaled?
All right. So we're looking at something greater than 1. All right. So if we're looking at something greater than 1, Rachel, what's a scale factor that's greater than 1?
An example is like 5 ones or like 2 ones.
Okay, yeah, that would work. So 5 would be our scale factor, or 2 would be a scale factor, and they're bigger than 1. And she was saying like 5/1, which we know that 5 divided by 1 is 5. And we know that 2 divided by 1 is 2. So if we have a scale factor of 2, or we had a scale factor of 5, what's happening to our links and our sides? Are they going to get reduced, stay the same, or are they going to enlarge?
They're going to enlarge.
Great. All right. So somebody give me a decimal version of a scale factor that's greater than 1.
1 2/3.
Well, that'd be a mixed number, but that would work. When I say decimal, I mean like 1.2 or 3.4.
1.9.
Great job. Great job. All right. So what about a fraction that's bigger than 1? What's a fraction that's bigger than 1? What type of fraction would that be called? Starts with an I.
Improper fraction.
That's right. An improper fraction would be a fraction that's larger than 1. So somebody give me an example.
12/24.
12/24 would still be 1/2.
5/2.
That'll work. 5/2 would work because 2 goes into 5 2 times, okay? And so let me show you the difference. So this is why 5 halves would work as an example. All right, so we have 5 halves. So we're going to see how many times 2 goes into 5. 2 goes into 5 how many times? 2 times. And when we subtract, we're left with 2 and 1 what?
2 and a fifth.
Not 2 and a fifth, 2 and a 2 and a half. Good job. So does everybody see how 5 halves is bigger than 1? Give me a thumbs up if you're understanding. Give me a thumbs down if you're not. All right, it looks like we're doing pretty good. Okay, so let's look at number 6 in our workbook. What does number 6 say? Read it for us, Levi.
You want me to do A as well? Read A as well.
Yeah.
Nadeem has a photo that is 5 inches tall and 8 inches wide. He plans to print copies of the photo in different sizes. For one of the copies, Nadeem enlarges the dimensions of the original photo by a factor of 3. What are the dimensions of the enlarged photo?
Okay, so what do you think we're going to have to do?
I think we have to multiply 5 and 8 by 3.
Okay. Does anyone agree or disagree? So this is what I want us to do. Since we're getting close to the end of our class, I would like us all to work on number 6 on our own. And then when we get into class tomorrow, we'll check our answer. Does that sound good? All right.
Yes, sir.
So at this time, what I want you to do, I want you to go ahead and log off. And those of you that needed help logging in to your Agile Mind, stay on, and I'm going to help you. Y'all have a great day, and I look forward to seeing you tomorrow.
You too.
Bye, Mr. Martin.
Bye-bye.